Hello friends, my name is Kisan and welcome you in this Spring transaction management video tutorial. In this video tutorial basically we are going to discuss about the Spring transaction isolation level. Transaction isolation level is a concept that is not exclusive to the Spring framework. It is applied to the transactions in general and is directly related to the ACID transaction properties. So if you haven't seen my previous video tutorial where I had explained about the ACID property, then I will recommend you to go and watch my previous tutorial. There I have explained what is ACID property. Isolation level defines how the changes made to the some data repository by one transaction affect other simultaneous concurrent transactions, and also how and when that changes data becomes available to the other transactions. When we define a transaction using the Spring framework, we are also able to configure in which isolation that same transaction will be executed. So I'm going to show you example like user example I have given. Using the @transactional annotation, we can define the isolation level of a Spring managed bean transactional method. This means that the transaction in which this method is executed will run with the isolation level. So here I have given an example like we have defined a method in service layer like transfer fund, which takes certain parameters, and within this method we are making call to the withdraw and deposit. So we want these two methods to be executed in the single unit of work. If any of the operation gets failed, then entire operation should be roll back. So in this top of the method I have used @transactional, and here we may specify some isolation level. So here I have specified one of the isolation level is called read committed. So here we have defined this method to be executed in the transaction which isolation level is read committed. So next video slides, in this video tutorial next slide I'll show you how many types of isolation levels are in a Spring framework. So before proceeding to understand isolation level, let's understand some of the problems occurs while our application interact with the database. So first problem is the dirty read. So in this picture you can see transaction A writes a record, meanwhile transaction B reads that same record before transaction A commits. Later transaction A decides to roll back, and now we have changes the transaction B that are inconsistent. This is called dirty reads. So transaction A makes some change, and meanwhile transaction B reads that change, but transaction later part of time transaction A decides to roll back that change. So data which is read by the transaction B is here dirty reads. So I hope you guys understood what is dirty read. Now second problem is the non-repeatable read. In this example, transaction A reads some record, then transaction B writes that same record and commits. Later transaction A reads that same record again and may get different values because transaction B made changes to that record and committed. This is called non-repeatable read. Now third problem we may get is phantom read. So in this example, transaction A reads a range of records, meanwhile transaction B inserts a new record in the same range that transaction A initially fetched and committed. Later transaction A reads the same range again and will also get the record that transaction B just inserted. This is called phantom read problem. To overcome this problem, Spring provides these are the isolation level. So first isolation level is the read committed. So read committed isolation level allows to read changes that haven't yet been committed. It suffers from the dirty reads, non-repeatable reads and phantom reads. But if you use this isolation level, then of course performance will be faster, but you may suffer if you are dealing with the concurrent transaction environment, then multi-threaded environment, then you may get these three problems: dirty reads, non-repeatable read and phantom read problem. Now second isolation level, we have a read committed. This allows reads from the concurrent transactions that have been committed. It may suffer from the non-repeatable reads and phantom reads, but you may prevent the dirty reads using this isolation level. Now third isolation level, we have a repeatable read. So multiple reads of the same field will yield the same result until it is changed by itself. It may suffer from the phantom read because other transaction may inserting the data. So if you use isolation repeatable reads, then of course you will be able to prevent the dirty reads and non-repeatable reads. Still you may get the phantom read. Now fourth isolation level, we have a serializable. Serializable isolation level is the most restrictive of all isolation levels. Transactions are executed with locking at all levels like read, range and writing locks. So they appear as if they were executed in a serialized way. This leads to the scenario where none of the issues mentioned above may occur, but in other way we don't allow transaction concurrency and consequently introduce the performance penalty. So if you use transaction isolation serializable, then all problems you may prevent the dirty reads, non-repeatable reads and phantom reads, but your transaction will be executed in the serialized fashion, so performance will be slow. Now here I have summarized the existing relationship between isolation level, read isolation level and read phenomena may be explained in the following table. Like you can see, if you use read uncommitted isolation level, then you may get all problems like dirty reads, non-repeatable and phantom reads. But if you use read committed, then your transaction is going to read only committed data. So you may prevent the dirty reads, but still you may get the issue like non-repeatable and phantom reads. If you use isolation level like repeatable read, then you may prevent these two problems like dirty reads and non-repeatable reads, but still you may get the phantom read problem. Now if you use serializable isolation level, then you may prevent all these problems like dirty, non-repeatable read and phantom read problem, but performance of your application would be very slow because your transaction will be executed in the serialized fashion. So you may not take the advantage of concurrency. So this may degrade your performance of your application. Here I have opened the Eclipse. So here look at here I have used a method in service layer. I have used a method like transfer fund, and here I am making call to these two methods, withdraw and deposit. And before this method we may use @transactional. So this is declarative transaction management in a Spring. Here I have used, here you may use a lot of attributes, but here in this video tutorial basically I would like to talk about the isolation level. So here read committed is the one of the enumerations. So if I press Ctrl and click over here, then here look at the here a Spring has a enum class which has declared this much type of the isolation level. So we talked about these four isolation level, but we didn't talk about the default one. So if you do not use isolation level, then Spring is going to use default one, and every database has a default isolation level. So that will be used by the Spring framework. Now here read uncommitted, read committed, repeatable read and serializable. These are the four isolation level we have talked about here. Now even though if you are not using a Spring framework, if you are using plain vanilla JDBC, then still you have this isolation level in the connection interface. So you have transaction read uncommitted, transaction read committed, transaction repeatable read, and finally you have a transaction serializable. And if you attach the Java source code, then you may get the explanation about this isolation level. Over here you may read these things. So that's all I wanted to teach you in this video tutorial. In next video tutorial I am going to talk about the something is called propagation level. So Spring framework provides some propagation level. When you use Spring transaction management, and here you can see we have used propagation level. If you go into this enumeration, then required, supports, mandatory, requires new, not supported, never, and nested. These are the propagation level you may use. So what is the significance of using this propagation level? We'll talk in the next video tutorial. So till that, happy learning guys, and thanks for watching my video tutorial.